Hi, today we're going to look at prime factorisation. I'll explain what that is in a minute. To start with, can you have a go at these three questions? And then I'm going to go through them. So first of all, got to remember that a prime number is a number that only has itself and 1 as factors. So 2 is a prime number, 3 is, 5 is, because for example 5 is just 5 times 1, there's nothing else that goes into it. 7 is, 9 however is 1 times 9, brilliant, but also 3 times 3, so it has additional factors, it is not prime. 11 is, 13 is, 17 is, 19 is, 21 is not, because 21 is 1 times 21, but it's also 3 times 7. 3 and 7 are its extra factors. So those are the two that you should have spotted. Note that 1 is not a prime number. It's more of a definition in this case, but you could say that it doesn't have 1 and itself as factors. It's just got one factor, which is 1. So that's one to be really careful about. You should become familiar with the prime numbers that are less than 20 and be able to kind of quote them really quite quickly. Even better if you can go up higher, or you've got a way of kind of, if you know your times table well, sometimes you can kind of rule some out, but they get a bit trickier. So say 57 is not prime because it's a multiple of 3. I think it's 3 times 19. Right, next question. Write down the factors of 24. Really good way of doing this is to start with 1 and 24 and like basically write down pairs that multiply together. So 1 and 24, and the next one you try 2. Yeah, 2 works and goes with 12. So write them as pairs. Don't write 1 times 24 though. It needs to be commas because we're writing down a list. And then 3, does that work? Yes, it does. 3 and 8. 4, does that work? 4 and 6. 5, no. 6, yeah, but we've already got that one. So we know at that point we've got them all. So that's quite a nice little strategy for small numbers to get all the factors. Finally, evaluate. Maybe you didn't know what this means. So it means, because I do get asked that, it just means calculate or work out. We want to know the actual number, but without a calculator. So if you didn't know that, like try it now and think about strategies for doing this quickly. I'll talk through some strategies. So one strategy is if you've got a 2 and a 5, that's brilliant because that gives us a 10 immediately. And then 2 times 2 times 2 is 8. So it's going to be 8 times 10 or 80. I don't need to do 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 5, what's that? Is 80. I can kind of take a little shortcut. Here, 2 cubed times 3 squared, well, let's work them out individually. It's going to be 8 times 9, which is 72. Here, this one's looking a bit trickier, but let's use our little kind of trick again. We've got 2 times, I might write it out, we've got 2 times 5, and we've got another 2 times 5, and then we're left with an extra 2 and a 7. So I'm going to get 10, that's 100. I'm going to times it by 14, so it's going to be 100 times 14, 1,400. Quite tricky to do it otherwise if you're trying to do 8 times 25 times 7, but maybe you did it that way. Last one, let's use that same trick once again. We've got 5 times 2, which is 10, and then we're going to have 3 times 2 cubed, which is 8. So it's going to be 24 times 10. It's going to be 240. Brilliant. Let's keep going then. So, in front of us, you might just want to think about what this is. You may recognize it. What is it? It's actually the periodic table, which in chemistry gives us the elements, these things that you can't easily like split up. They basically are the building blocks of the world around us. For example, water is H2O, 2 lots of hydrogen and 1 oxygen. Table salt is NaCl, sodium chloride. And so we get all these kind of things we're really used to, and they're made from these individual elements. Well, how does that link to our lesson? In maths, the prime numbers are our elements. They're the things that make up everything else. Because every number bigger than 1 is either prime or is made of a product of prime numbers. So you could say that 5 is prime, whereas 10 is made of a product. Product, by the way, means multiply. So 2 times 5. You need to remember that. if you're asked to write a product of prime numbers, it's going to be prime numbers multiplied together. So 5 prime, 10 is then made up, it's a bit like the H2O, whereas the oxygen is the prime. And we can use that then to split numbers into their prime factors, which is precisely what I mean by prime factorisation. So a number 6 can be written as a product of its prime factors. It's 2 times 3, and I'd already spoken about 10 being 2 times 5. And actually, the way we often do this is to use factor trees. I kind of went straight to it, but you could say, yep, we've got 2 and 3. I'm going to circle them. I'm going to do a little bit more on this in a minute. And with 10, it's 2 times 5. Get this little factor tree coming out. So just going to write this out again. 2 times 3, 2 times 5. So I just want you to pause the video and think, how could you possibly write 60 as a product of its prime factors using what we've just done? Well, we can see that 60 is 6 times 10, but I've already got the product of prime factors for 6, so it's going to be 2 times 3, and I've already got the product of prime factors for 10, 2 times 5. And there we have it. We've written it as a product of its prime factors. Now you could rewrite it as 2 times 2 times 3 times 5 to order it. And there's one other way we could write it, which I'll talk about in a second. So we can kind of split these things up. And here's what you could do if you're going from scratch. A factor tree right from the beginning. So split 6 into 6 and 10. They're not prime. So do another factor branch coming off of it. 2 and 3, circle them, we're done. And the same for 2 and 5. Just to say, there's more than one way of doing it. So we could have gone with 2 and 30 as our first branch, circle the 2, split the 30 into 2 and 15, circle the 2, and then the 15 becomes 3 and 5. Notice we get exactly the same prime factors each time. Not a coincidence. This is the building blocks to make 60, 2, 2, 3, and 5. We can write it like this, and here's the other way we can write it, index form. Now, just to say that when you write something like x to the power of b, okay, this thing here, sometimes it's called the power, but sometimes it's called the index, and that is singular for indices. So if you're asked to write something in index form, it means you can't just leave it as this. You have to get it in like that. 2 times 2 is 2 squared. Be really careful. The other thing that it is sometimes called as power or index is the exponent. That's probably the one you've not seen before. Exponents. So be aware of powers, indices or index, and exponents. All right, well, if you're feeling confident, I'd like you to try and write 150 as a product of its prime factors in index form. Go for it. By the way, sometimes I see people have different techniques for this. I'm going to teach it this way. I'm not going to talk about any other ones, as long as you've got a method that works. Right, 150. I think a good shout is to get the 10 sorted, because 10's quite nice to sort out. We just get the 2 and the 5. We could have started with 2 and 75. It's just that immediately feels more complicated. And then for 15, we get 3 and 5, and these are also prime. So we're done. We can write down that 150 is equal to 2 times 3 times 5 times 5, or in index form, because that's what we're being asked for, 2 times 3 times 5 squared. Have a go then at this task. So I'm just going to show you the answers. Here we go. By the way, one of the answers is wrong, I've realised. 6 squared, that is equal to 36, but it's not the prime factorisation. It should be 2 squared times 3 squared. And yet 25 is a square number, we just write it as 5 squared. Question 2 looks really confusing, but it's basically just asking us to write 120 as a product of prime factors. It's actually giving us what it will look like at the end. So the answer is this, and it would have been 2 to the 3 times 3 times 5. So if you got that, you're basically there. You just got to then, it just wants you to then say what M, N, and P are. So just be careful with this sort of thing. And then an extension question. How about these ones? They're a little bit larger. Think about C carefully. Well, I'd split it up into the 225 times 10 and go from there. You actually get this as the answer. 1,350. And you don't have to multiply this all together and then find the product of prime factors. All you need to do for this last one is multiply these two together and sort out the indices. So it becomes 2 times 2, which is 2 squared, 3 squared times 3 cubed. You add the powers to get 3 to the 5, 5 to the 3 times 5 squared, 5 to the power of 5. So you can quickly do these sorts of calculations if you know the prime factors of the two numbers. How about this one? Using 60 equals 2 squared times 3 times 5, write the following numbers as products of their prime factors. You don't need to do factor trees, you need to try and link it to what is up here. Hopefully you've paused the video, tried this out. Here goes then. So 120, we recognise actually we just do 60 times 2, which is just this 2 squared times 3 times 5 and times it by an extra 2. We then add 1 to the power of 2. So that's the answer. 180, very similar, but we're timesing by 3. So we add 1 to that power. 20, we're going to actually divide through by 3. So that's going to be, when we divide through by 3, it's going to go, we're left with 2 squared times 5. 600 times through by 10. So we get an extra 2 under 5. Becomes 2 cubed times 3 times 5 squared. And finally, 360, it's going to be timesing through by 6. So add 1 to the power of 2, and 1 to the power of 3. Brilliant. That's mainly our first lesson on prime factorisation. You've got to know these words. Prime, I'm going to highlight them actually. Prime factorisation, make sure you know what that means. Make sure you know what prime means and factor means. Well, be aware of the word evaluate as well. So it just means calculate or work out. We've talked about this, and then here's the other one: product of prime factors. It's an absolutely crucial one, because if you might be able to do this. You might think, "Yep, I can do factor trees and write them out." But if you forget what product means, then it's you're gonna get in some difficulty. It means times. By the way, sum of two numbers means you add them. Difference would normally mean you subtract them, but you tend to not include the negative. So the difference between 2 and 7 is 5. Difference between 7 and 2 is still 5. You're finding out how you go from one to the other, but you're not interested in the sign. Just one more thing to try. If you fancy it, this is my extension, my super extension, let's say, for today. A prime factor tessellation. So we've got loads of numbers here. They can all be expressed as a product of 4 prime numbers. Can you work out the prime factors and arrange them so that each number is surrounded by its prime factors? So let me give you an example. I'm just going to go through one. So 24 is going to be 6 and 4. And then it's going to be 2 and 3. And 2 and 2. Now I need to put these in, but I need to make it so it works. I can't just do this and hope it works. I need to think about it. I need to think, maybe the 2 should be there, maybe the 2 should be there. So I don't think I know at the moment, because I don't think 3 doesn't go into 140. So I know that has to be 2, because it couldn't be 3, because 140 has to be. Let's do 140 as well. So 140, it's going to be 10, 14, 2, 5. So you're going to be doing lots more factor trees like this. So I've got to think where the 7 goes, and the 2 goes, and the 5 goes. Well, okay, 5 can't go here because 5 doesn't go into any of the other ones. It can't go here because it doesn't go into 126. It can't go here because it's a 24. It's going to have to go there. So basically, you need to try and solve this as a bit of a puzzle using this kind of idea. I'm not going to explain it anymore. If you have tried it, brilliant. Here's what I got as the answers. Fantastic. Your prime factorization is looking in good shape.